Hello, and welcome to Deep Sleep Science. Tonight, we turn our gaze upwards. Not to a distant stranger, a foreign galaxy, or a mysterious black hole, but to our own home. Our own backyard. Tonight, we explore the Milky Way. It is the city of stars in which we live. A vast, spiraling metropolis of light hanging in the void of intergalactic space. It is a structure so immense that light transforms from a fast messenger into a slow traveler when crossing it. To fly from one side to the other at the speed of light would take you 100,000 years. It is home to at least 100 billion stars. Some estimates say 400 billion. Each one a sun, each one a potential anchor for worlds, for planets, for life. And amidst this unimaginable swarm, drifting in a quiet suburb, sits our own sun, a single grain of sand on a cosmic beach that stretches beyond the horizon of our imagination. Look up on a clear, moonless night, far from the glare of city lights. You will see it. A faint glowing band arching across the sky. A river of milk spilled across the heavens. That band is the disk of our galaxy, seen edge on. It is the collective light of billions of distant stars, too far away to be resolved as individual points, blending together into a celestial fog. For thousands of years, humans have looked at this band and wondered. They wove stories, myths, and legends to explain its presence. And now, in the age of science, the reality we have uncovered is even more majestic than the myths. Tonight, let go of the earth. Let go of the ground beneath your feet. We are going to float. We will rise up, out of the solar system, out of the Orion Arm, and take a tour of our magnificent, spiraling home. We will trace its history, marvel at its geography, and peer into its heart. We will understand what it means to be a citizen of the Milky Way. Relax, breathe, and let the stars surround you. Before we understood the physics, we understood the beauty. Every culture that has ever looked up has seen the Milky Way and told a story about it. The name itself, Milky Way, comes to us from the ancient Greeks. Galaxias Kyklos, the Milky Circle. They believed it was the milk of the goddess Hera. The legend goes that Zeus, the king of the gods, placed his infant demigod son Heracles at Hera's breast while she slept, hoping the divine milk would grant the boy immortality. Hera woke up, startled to find a child she did not nurse suckling at her. She pushed him away, and a spray of milk spilled across the sky, staining the heavens forever white. The Romans adopted this, giving us the Latin Via Lactea, the Milky Road. But other cultures saw different things. To the Cherokee people of North America, it is Giliut Sunstan Yun, where the dog ran. A spirit dog stole cornmeal from a mill and ran across the sky, spilling the white flour as he fled. In Finland, it is Linnunrata, the path of the birds, a guide for migratory birds flying south for the winter. In vast parts of Asia, it is a river. In Chinese mythology, it is the Silver River, a celestial barrier separating two lovers, the cowherd and the weaver girl. They are allowed to meet only once a year on the 7th day of the 7th lunar month, when a flock of magpies forms a bridge across the river. In India, it is the Akashganga, the Ganges of the sky, a sacred river flowing through the heavens before it falls to earth. For the Bushmen of the Kalahari, it was created when a girl threw the ashes of a campfire into the sky to help a hunter find his way home in the dark. The white-hot ashes became stars, and the drifting smoke became the Milky Way. Milk, flour, birds, water, ash. All of these stories share a common feeling, intimate connection. The Milky Way was not a distant, cold astronomical object. It was part of the world. It was a path, a river, a trail. It was something that connected the sky to the earth, the gods to the mortals. It was a reminder that we are small, but we are watched over. Tonight we keep that sense of connection, but we replace the milk and the flour with plasma and dust. We replace the river goddess with gravity. The story changes, but the wonder remains. How do we begin to comprehend the size of our galaxy? The human mind is built to understand distances in meters, kilometers, perhaps thousands of kilometers. We understand the walk to the store. We understand the flight across the ocean. But a galaxy? Let us try to build a model. Imagine the sun as a grain of sand. A tiny, shining grain of sand, perhaps 1 millimeter across. On this scale, the Earth is a microscopic speck of dust, orbiting about 10 centimeters away. Pluto is 4 meters away. Where is the next nearest star, Proxima Centauri? If the sun is a grain of sand here in your hand, Proxima Centauri is another grain of sand. 30 kilometers away. Think about that. 30 kilometers of empty space between 2 grains of sand. And that is just the nearest neighbor. Now imagine the Milky Way. On this scale, our galaxy is a collection of 200 billion grains of sand. It would span 700,000 kilometers. That is nearly twice the distance from the Earth to the Moon. A disk of sand, twice the size of the lunar orbit, scattered with vast emptiness between every grain. In reality, the Milky Way is a disk approximately 100,000 light-years in diameter. A light-year is the distance light travels in 1 year, about 9.46 trillion kilometers. 100,000 of them. It is a thin disk, relatively speaking, like a vinyl record or a DVD. It is about 1,000 light-years thick on average, although it bulges in the center. If you could view it from outside, perhaps hovering 1 million light-years above the galactic North Pole, you would see a stunning pinwheel. A glowing, flat spiral with a bright, yellowish-white center and long, graceful blue-white arms curving out into the darkness. It is not still. It is spinning. The entire galaxy rotates, but not like a solid plate. The inner parts spin faster than the outer parts in a complex dance of differential rotation. Our sun, located about halfway out from the center, completes one orbit every 230 million years. The last time we were in this part of the galaxy, dinosaurs were just beginning to evolve. The continents on Earth were fused together in the supercontinent Pangaea. We have traveled a long, long way since then. We are travelers on a great carousel, riding a star through the dark. Let's look closer at the structure. The Milky Way is a barred spiral galaxy. For a long time, we thought it was just a simple spiral. But infrared telescopes, which can peer through the dust clouds that block visible light, revealed a massive straight bar of stars running through the center. Imagine a fireworks wheel. In the center, a bright, straight bar of old yellow stars. From the ends of this bar, 2 major spiral arms unfurl, wrapping around the galaxy. These are the Scutum Centaurus arm and the Perseus arm. These are the major highways of the galaxy, dense with gas, dust, and young stars. There are also minor arms, like the Sagittarius arm and the Norma arm. And where are we? We are not on a major arm. We live in the suburbs, in a quiet little offshoot called the Orion Spur. We are a bridge between the Sagittarius and Perseus arms. It is a good place to be. The major arms are chaotic. They are regions of intense star formation where massive stars live fast and die young, exploding as supernovae. The radiation in the major arms is intense. Out here in the Orion Spur, things are a bit calmer. We have enough gas to form stars, but we are not crowded. We are in the Goldilocks zone of the galaxy itself. Not too close to the dangerous core, not too far out in the barren halo. Just right. Why does the galaxy have arms? It is not because the stars are physically connected like the spokes of a wheel. If they were, the arms would wind up and disappear after a few rotations because the inner stars move faster. Instead, the spiral arms are density waves. Think of a traffic jam on a highway. Cars slow down, bunch up, and then speed up again. The jam stays in one place while the individual cars move through it. The spiral arms are cosmic traffic jams. Stars and gas clouds slow down as they pass through these regions of higher gravity. When gas clouds slow down and bunch up, they get compressed. Compression triggers collapse. Collapse triggers star formation. So, the spiral arms are like a lighthouse beam sweeping through the galaxy, lighting up with blue-hot young stars wherever the wave passes. The wave moves on, leaving behind the new stars, like a wake behind a ship. When we look at the spiral arms, we are seeing the galaxy's maternity wards, the places where the universe is renewing itself. Surrounding the flat, shining disk is a different structure. A ghost, the galactic halo. While the disk is flat and filled with gas and dust, the halo is a vast, spherical cloud of stars that envelops the entire galaxy. But these are not like the stars in the disk. The disk stars are like our sun, relatively young, rich, and heavier elements. The halo stars are ancient. Some of them are nearly as old as the universe itself, 13 billion years old. They are the survivors of the first generations. They are metal poor, burning dimly, wandering in lonely, elliptical orbits that take them high above and far below the galactic plane. They are the majestic elders of the city, watching from the hills. Floating within this halo are the globular clusters. These are stunning jewels, tightly packed balls of hundreds of thousands of stars held together by their own gravity. Imagine a sky where, instead of a few thousand scattered stars, you saw tens of thousands blazing like a wall of light. That is the view from a planet inside a globular cluster. There are about 150 known globular clusters orbiting the Milky Way. They are like many galaxies, fossils from the time the Milky Way was forming. They circle the galactic center like bees buzzing around a hive. The halo has no gas, no dust. No new stars are born there. It is a place of preservation, a museum of the early cosmos. If you were to float in the halo, looking down, you would have the ultimate view. You would see the great, glowing spiral of the Milky Way suspended against the absolute black, a flat, spinning jewel box, with the blue arms dusting the void and the golden core burning in the center. a sight no human has ever seen, but a sight we can see in our minds. Let us descend now, down from the halo, plunging back through the disk and traveling inward, towards the center, the galactic bulge. As we approach the center, the sky changes. In the suburbs where Earth resides, the stars are scattered like diamonds on black velvet. But here in the bulge, the sky is a wall of fire. The stars are packed so tightly that a night sky on a planet here would be bright enough to read by. The bulge is a peanut-shaped swarm of old red stars about 10,000 light-years across. It is the downtown district of the galaxy. Crowded, chaotic, old, but deeper still, hidden behind curtains of thick interstellar dust, lies the true center, the nucleus. For decades, astronomers knew there was something strange there, a powerful source of radio waves. They called it Sagittarius A. We could not see it with optical telescopes. The dust was too thick. But with infrared eyes, we watched the stars in the very center. And we saw them dancing. We saw stars whipping around an invisible point in space at millions of kilometers per hour, like moths circling a flame. Using the laws of gravity, we weighed the invisible object. It has the mass of 4.1 million suns. It is squeezed into a space smaller than the orbit of Mercury. It is a supermassive black hole. It is the anchor of our galaxy, a quiet monster. Unlike the blazing quasars in the early universe, our black hole is currently on a diet. It feeds only on the occasional wisp of gas or an unfortunate asteroid. But every now and then, it flares up, sending a pulse of X-rays echoing through the molecular clouds around it. It is a reminder that even in the heart of our home, there is a sleeping dragon. Surrounding this black hole is the central molecular zone, a ring of dense gas clouds rich in complex molecules. Alcohol, sugar, amino acids, the building blocks of life are floating there in the dark, waiting to be part of a new world. Leaving the dangerous core, we travel back out into the spiral arms. Here, we find the true beauty of the Milky Way, the nebulae. If stars are the citizens of the galaxy, nebulae are the maternity wards. These are vast clouds of gas and dust glowing in ethereal colors. Pinks, teals, golds. They are the most photogenic objects in the universe. Consider the Orion Nebula, visible to the naked eye as a fuzzy patch in Orion's sword. It is a cavern of illuminated gas carved out by the ultraviolet radiation of 4 massive newborn stars called the trapezium. Inside these clouds, a miracle is happening. Gravity is pulling clumps of gas together. The gas gets denser, hotter. Eventually, in the deep dark heart of a cloud, a spark catches. Nuclear fusion begins. A star is turned on. Around these infant stars, swirling disks of dust are forming planets. We can see them with our telescopes, protoplanetary disks. Solar systems in the making. It is a messy, violent, beautiful process. The pillars of creation, the mountains of mist. But not all nebulae are nurseries. Some are graveyards. When a star like our sun dies, it gently puffs off its outer layers, creating a planetary nebula. These are round, colorful, symmetrical shells of gas, glowing like cosmic jellyfish. The Rin Nebula, the Cat's Eye Nebula. They are the final breaths of dying stars, enriching the galaxy with carbon, nitrogen, and oxygen, the elements of life. You are made of this stardust. Every carbon atom in your cells, every oxygen atom in your lungs, was once inside a star that died and breathed its ashes into the galaxy. The Milky Way is not just around you, it is inside you. Who lives in this city? We categorize the stars into two main families, which we briefly met in the halo: Population I and Population II. It is a slightly confusing naming convention because Population I stars are actually the younger ones. Population II are the old ones. Why? Because astronomers are terrible at naming things. Population I stars are the metal-rich stars. They live in the disk, in the spiral arms. They formed from gas that had already been enriched by previous generations of supernovae. They define the visible structure of the galaxy. Population II size are the metal-poor ancestors. They roam the halo and the bulge. But there is a rumored third population. Population III. These would be the first stars, the very first luminous objects to form after the Big Bang, made of pure hydrogen and helium. No metals at all. We have never seen one. They were likely massive, burning out quickly and exploding eons ago. They are the mythical founders of the city, their names lost to time, their bodies turned into the black holes that seeded the early galaxies. And within these populations there is diversity. Red dwarfs, the most common stars. Tiny, cool, and dim. They burn so slowly they will live for trillions of years. Long after the sun has died, the red dwarfs will still be glowing. They are the silent majority of the Milky Way. Yellow dwarfs, like our sun. Stable, warm, perfect for life. Blue giants, the rock stars. Massive, hot, and brilliant. They burn their fuel with reckless abandon, living only a few million years before exploding. They are rare, but they are so bright they define the spiral arms. When you look at a galaxy and see blue arms, you are seeing the light of these short-lived giants. Let's look at the sky from Earth again using this knowledge. When you see the Milky Way, you might notice it is not a solid band. There are dark patches, black rivers running through the white light. This is not empty space. This is dust. The Great Rift. A dark lane of molecular clouds that splits the Milky Way in two, stretching from Cygnus to Sagittarius. It looks like a shadow, but it is construction material. Cold, dense dust that blocks the starlight behind it. The Aboriginal astronomers of Australia saw this dark patch not as an absence of stars, but as an object itself, the emu in the sky. A giant dark bird stretched across the heavens. And then there is Barnard's Loop, a vast, faint ring of red gas circling the constellation Orion. It is likely the remnant of a supernova explosion that happened 2 million years ago. A shock wave frozen in time, blowing faintly in the night. The history of the galaxy is written in these scars and shadows. Nothing is standing still. We are moving. The sun orbits the center at about 200 kilometers per second. But not all stars move together. There are high-velocity stars, stars that are moving so fast they are escaping the galaxy. How does a star get kicked out of the city? Usually it involves a three-body interaction with a black hole. A pair of stars wanders too close to the supermassive black hole, Sagittarius A. The black hole captures one star and unstoppably slingshots the other one outward. These stars scream through the galaxy at millions of kilometers per hour, destined to leave the Milky Way and drift forever in the intergalactic void. Cosmic exiles. And then there are the majestic movements of the spiral arms themselves. We are currently passing through the Orion Spur, but we haven't always been here. As the sun orbits, it passes in and out of the spiral arms. Some scientists believe these passages through the arms are dangerous times for Earth. The arms are full of supernovae. A nearby explosion could strip our ozone layer. Or perhaps the higher density of dust blocks sunlight, causing ice ages. Others argue the arms are necessary for life. The supernovae provide the heavy radioactive elements that heat Earth's core, keeping our planet geologically active. We are travelers, surfing the density waves of the galaxy, and our history is tied to the rhythm of this ride. Everything we have described so far, the stars, the gas, the dust, the black hole, makes up only a tiny fraction of the mass of the Milky Way. About 10 to 15%. The rest, we cannot see it. Generations of female astronomers, most notably Vera Rubin, noticed something strange. When they measured the rotation speed of galaxies, they expected the outer stars to move slower than the inner stars, just like Pluto moves slower than Mercury. But they didn't. The outer stars were moving just as fast. By all laws of physics, they should be flinging themselves off into space. The visible gravity was not enough to hold them. There had to be something else. Invisible glue. Dark matter. The Milky Way is embedded in a massive dark matter halo, a sphere of unknown particles that extends far beyond the visible stars. It is the scaffolding that holds the galaxy together. We don't know what it is. WIMPs, axions, primordial black holes, but we know it is there. Without it, the Milky Way would fly apart. We are living in a nice, lit house, but the foundation is made of mystery. Every time you look at the Milky Way, remember, you are seeing only the tip of the iceberg. The glowing foam on top of a deep, dark ocean. Our galaxy is not alone. It has an entourage. Orbiting the Milky Way are dozens of smaller dwarf galaxies. The most famous of these are the Magellanic Clouds. Visible only from the southern hemisphere, they look like detached pieces of the Milky Way, floating alone in the dark. The Large Magellanic Cloud and the Small Magellanic Cloud. These are irregular galaxies. They don't have beautiful spirals. They are messy, chaotic blobs of gas and stars. But they are alive. The Large Magellanic Cloud is actually a powerhouse of star formation. It contains the Tarantula Nebula, the most active star-forming region in the entire local group. If the Tarantula Nebula were as close to us as the Orion Nebula, it would cast shadows on Earth at night. It would be huge. These clouds are dancing with the Milky Way, and they are doomed. Gravity is a cruel master. The Milky Way is slowly ripping them apart. As they orbit, a long ribbon of gas is being pulled off them. The Magellanic Stream. It trails halfway around the sky, a bridge of hydrogen connecting the clouds to us. Eventually, in a few billion years, they will fall in. They will be consumed. Their gas will fuel a new burst of star formation in the Milky Way, and their stars will become our citizens, immigrants to the big city. But there is another galaxy even closer, one that we didn't discover until 1994 because it is hiding. The Sagittarius dwarf spheroidal galaxy. It is actually inside the Milky Way right now, or rather, passing through the disk on the other side of the core. The Milky Way is currently eating it. Gravity has stretched it into a long loop of stars that wraps around our galaxy like the ribbon on a present. This little galaxy has crashed through the Milky Way's disk at least 3 times in the past. Some astronomers believe these crashes are what triggered the spiral arms to form in the first place. Every time Sagittarius punches through, it sends ripples through the disk, waking up the gas and triggering starbirth. It is even possible that our own solar system was born from a wave of star formation triggered by one of these collisions 5 billion years ago. We might owe our existence to a galactic fender bender. Zooming out further, we leave the Milky Way's halo and enter the local group. This is a collection of about 54 galaxies. Most of them are tiny dwarfs. But there are 3 giants. The Milky Way is the second largest. The third largest is Triangulum, a beautiful, small spiral. And the ruler of the local group? Andromeda. It sits 2.5 million light-years away. You can see it with your naked eye on a dark night, a faint smudge in the constellation Andromeda. It is the furthest object a human eye can see without a telescope. Think about that. When you look at that smudge, you are seeing light that left 2.5 million years ago. Before humans existed, before the ice ages. Andromeda is a monster. It contains maybe 1 trillion stars, twice as many as the Milky Way. For a long time, we thought it was just a bigger version of us, but recent studies show it is a bit messy. It has a double nucleus. Its disk is warped. It has likely eaten many galaxies in its past. It is a cannibal, and it is looking at us. But the local group is just a small village. Where is our village? We are part of the Virgo supercluster, a vast sheet of galaxies stretching for millions of light years. But even that is just a limb. In 2014, astronomers mapped the flows of thousands of galaxies and realized that the Virgo supercluster is just an appendage of something much, much bigger. Laniakea, immeasurable heaven in Hawaiian. Laniakea is a supercluster of 100,000 galaxies. It spans 520 million light-years. It looks like a giant glowing feather or the neurons of a brain. And everything in it, the Milky Way, Andromeda, Virgo, is flowing towards a mysterious point in space called the Great Attractor. We can't see exactly what the Great Attractor is because it is hidden behind the dust of our own Milky Way. But we can feel its gravity. It is pulling us. We are sliding down a gravitational river along with thousands of other galaxies towards a rendezvous, hundreds of millions of light-years away. We are small, so very small, but we are part of a flow that is darker, deeper, and more majestic than we ever dreamed. Let's pause the journey for a moment and return to the human scale. We talk about years, millions of years, light years. But what does it feel likely to live in this galaxy? It feels like stillness. We wake up. We drink coffee. We go to work. The ground feels solid. But in reality, you are a traveler on a spaceship that is moving at dizzying speeds. The Earth spins at 1,600 kilometers/h. It orbits the Sun at 107,000 kilometers/h. The Sun orbits the galactic center at 828,000 kilometers. The galaxy falls towards Andromeda at 400,000 kilometers. And the whole local group falls towards the Great Attractor at 2 million kilometers/h. Right now, as you lie there, you're moving faster than a bullet. Faster than a rocket. You are tearing through the cosmos, but gravity holds you. The atmosphere protects you. The vast distances make the motion seem like stillness. We are protected by the sheer scale of the void. If space were crowded, we would feel the wind. We would see the blur. But space is empty. And so we sleep safe in our high-speed cocoon. We mentioned earlier that we live in the Goldilocks zone of the galaxy. Let's expand on that. Is life common in the Milky Way? Drake's equations suggest there should be thousands of civilizations. But we haven't heard them. The Fermi paradox. Where is everybody? Perhaps location matters. If you live too close to the core, the density of stars is too high. A supernova goes off every Tuesday. Radiation sterilizes your planet. Asteroids are constantly knocked out of orbit by passing stars. It is a war zone. If you live too far out in the halo, there are no metals. No iron to build a planet core. No silicon to build rocks. No carbon to build life. Just gas balls. You need to be in the middle. The galactic habitable zone. A ring of life circling the core. We are right in the middle of it. And even here, we need luck. We need to stay out of the spiral arms. We need a quiet star. Maybe the Milky Way is full of life. But maybe the forest is so big and the trees are so far apart that we are all just shouting into the wind, unheard. Or maybe, just maybe, we are the first. The first to wake up. The first to look up. The responsibility of that thought is heavy. If we are the only eyes of the Milky Way, then we are the universe's way of knowing itself. If we destroy ourselves, the galaxy goes blind. We have spoken of the past and the present. Now, we must look to the future. The future is dominated by one single event. The collision. Remember Andromeda? The giant spiral 2.5 million light-years away? It is falling towards us at 110 kilometers per second. Every hour it gets 400,000 kilometers closer. It is inevitable. In about 4.5 billion years, just as our sun is swelling into a red giant, Andromeda will arrive. It will be a spectacular sight for any life left on Earth. For millions of years leading up to it, Andromeda will grow larger and larger in the night sky. It will cease to be a smudge and become a giant glowing vortex spanning the entire horizon. The two galaxies will not slam into each other like cars. They are mostly empty space. The stars will pass right by each other. It is unlikely that any two stars will actually collide. But the gas will collide. Tidal forces will rip the spiral arms apart. The beautiful pinwheels will be distorted. Long streamers of stars will be flung out into the void. The night sky will be a chaos of arcs and bridges. The gas clouds will be compressed, triggering the greatest burst of star formation in the history of both galaxies. The sky will blaze with thousands of new blue stars and hundreds of new supernovae. It will be a cosmic firework display lasting 1 billion years. Eventually, the chaos will settle. The two black holes, Grow A and Andromeda's monster, will spiral inwards and merge. The two spirals will lose their shape. They will become a single, giant, elliptical ball of stars. A new galaxy. Astronomers call it Milkomeda, or Milkromeda. It will be a red, dead galaxy. Most of the gas will be used up in the collision. Star formation will stop. The blue stars will die out. Milkomeda will be a quiet, golden giant drifting alone in the dark. Let us cast our minds even further. 100 billion years from now. The universe is expanding. Dark energy is pushing galaxies apart. By this time, all the other galaxies outside the local group will have accelerated away from us faster than the speed of light. Their light will never reach us again. They will vanish from the sky. To a civilization born in Milkomeda in the far future, the universe will look empty. They will see their own galaxy a vast island of stars. But looking out, they will see nothing. No other galaxies. No cosmic web. Just infinite, eternal blackness. They might conclude that their galaxy is the entire universe. They might develop laws of physics that say space is static and finite. They will have no way of knowing about the Big Bang. No way of knowing about the expansion. No way of knowing about the rich, crowded history we see today. We are privileged. We live in the time of light. We live in the time when the universe is knowable. We can see the neighbors. We can see the past. In the distant future, the evidence of cosmology will be erased by the darkness. But do not despair. Even in a dead galaxy, there is life. Red dwarf stars live for trillions of years. Planets will still circle them. Life might still evolve, huddled around these dim embers. And matter's recycled. Stars die, but they leave behind white dwarfs, neutron stars, black holes. These remnants will dance. Occasionally, they will collide. Kilonova explosions will sprinkle gold and platinum into the void. The galaxy will dim, but it will not disappear. It will settle into a long, slow fade. A twilight that lasts for eternity. And at the center, the supermassive black hole will reign supreme, watching over its kingdom of ghosts. Before we conclude, we must look at one last structure. A structure that was invisible until 2010. The Fermi bubbles. We tend to think of the Milky Way as a flat disk. But if you could see in gamma rays the highest energy light in the universe, you would see something shocking. Two giant glowing bubbles of energy erupting from the center of the galaxy. One rising 25,000 light-years up above the disk, and one stretching 25,000 light-years down. They look like the number 8, with the galactic center at the waist. what created them. It was likely an outburst from Sagittarius A. About 6 million years ago, the black hole had a feast. It swallowed a large cloud of gas, or perhaps a star. It burped a jet of energy that blew these bubbles out into the halo. The gas inside them is moving at 2 million miles per hour. It is a reminder that our galaxy is not just a peaceful spiral. It is a breathing, erupting beast. It has a history of violence that we are only just beginning to uncover. And the disk itself? It is not perfectly flat. It is warped. Like a vinyl record left in the sun, the outer edges of the Milky Way are bent. One side curls up, the other curls down. Why? It is likely the gravitational tug of the Magellanic Clouds we met earlier. They are twisting the galaxy as they orbit. Or perhaps it is the lingering ripple of a past collision. Nothing is perfect. The Milky Way is scarred, bent, and blowing bubbles of gamma radiation. And that imperfection is what makes it real. Let us return now. Back from the future. Back from the collision. Back from the halo. Back to the Orion Spur. Back to the solar system. Back to Earth. Look out your window. Or close your eyes and imagine the night sky. That band of light. That river of milk. It is not just a stain on the sky. It is a city. It is a history book. It is a future. We are small, yes, but we are part of something magnificent. We are the consciousness of the galaxy. We are the way the Milky Way thinks about itself. When you sleep tonight, you are not just sleeping in a house, in a city, on a continent. You are sleeping in the spiral arm of a grand, rotating, flying, evolving, living galaxy. You are a child of the Milky Way. And you are home. Drift now. Let the rotation of the galaxy rock you to sleep. Let the light of 100 billion stars watch over you. The universe is vast. The night is deep, but you are safe. You are part of the flow. Sleep.